Here's your notes for section 2.5. Guess what? We are still solving equations. Yay! Except for this time, the variables are going to be on both sides of the equation. So it's going to cause probably a little bit more confusion and more questions of like, how do I know where to put the x? Or how do I know where to put the numbers? It was easy before when we had all x's on one side, we just put the numbers on the other side. This time, we're going to have to do a little work. First, we're going to do the distributive property. So getting rid of the parentheses is still going to be taken care of first, if you want to put parentheses by that. But then, to get the variable on one side, we are going to have to undo it by adding or subtracting. And we're going to have to undo by adding or subtracting with the x's, or the variables, whatever the variables are. We'll have to do the variables first. Add or subtract the variables over to the other side. Then we will do it with the numbers. So it is technically probably that step 2 and 3. Undo addition or subtraction with variables. Then undo addition or subtraction with numbers. Which then would make our last step, step 4 you could maybe call it, then we get rid of any multiplication or division. That still comes last, just like it's been last in all of the examples that we've done so far. We'll just walk our way through it nice and slowly. You can always pause and rewind. We'll start with a couple of shorter ones that don't have distributive property first, so we can get right away to this second step to get the variable on one side. We are going to either put these 4x's over to that side of the equation, or we could put those 8x's over to the other side of the equation. I am going to choose one method, and I'm going to do the same method every single time. Doesn't mean it's right, doesn't mean it's easier, doesn't mean that you have to do it that way every time, but I'm going to do it to stay consistent, and I kind of know that we're going to start doing inequalities with less than and greater than signs, and then it makes more sense to always go to the left side. So knowing that that's coming, I'm always going to take however many x's we have here and move them over to the left side of the equation. This 4x is positive. Forget that this is a subtraction problem. The 4x is positive, so I'm going to minus 4x from it because 4x minus 4x cancels it out. Still, the rule is whatever you do to one side of the equation, you must also do to the other side. Make sure you line it up with the x's. Like terms have to stick together. What you have left with is a 7. Drop it down. Negative 8 and negative 4, or negative 8 minus 4, is negative 12x. Use your calculators when you've got the double negatives like that. Don't get goofed up by your head. Equals negative 17. So now we're right back to a two-step solving problem, which we've done, for a few days now. We've got our x's on one side. So undo adding or subtracting. Undo with adding or subtracting with the variables first. Did that. We still have to do more adding and subtracting with the numbers. And since we decided that all of our x's are going over there, and if you need to, throw your stripe down the equal sign. Get your x's are on that side. Get your numbers over here on this side. Again, don't be fooled by the subtraction sign. This 7 is positive, so we're going to subtract 7 from it. 7 minus 7 is gone. Whatever you do to this side of the equation, you have to do to this side of the equation. What are you left with? Negative 12x equals negative 24. Step 1, we moved the x's. Step 2, we moved the numbers. They both went the exact opposite way of each other. Step 3, divide. Get rid of the negative 12 times x. You have to divide by negative 12. And if you divide by a negative, it takes care of that right away. And x equals a negative divided by a negative is a positive 2. Little bit different checking our answers this time. Not going to be able to just type it in on a calculator and hit equals. A little more work to do on this, but it doesn't mean you shouldn't still check your answers. You're going to put a 2 in up here for the x and type in 7 minus 8 times 2, and you'll get negative 9. Then put the 2 in over here for the x. 4 times 2 minus 17, and you get negative 9. So instead of checking to see if you get the answer, you're going to check to see if the left side of the equation balances and is equal with the right side of the equation. So there's one problem. We'll do another one. Notice it's different. The first one just had 3 steps to it. This one we're going to have to add that distributive property in. 5z minus 2 equals 2 times 3z minus 4. Careful your handwriting. Make sure that you make your z's distinguishable. It looks like we have 2 z's and 2 2's in there. That's why, if you haven't noticed yet in my teaching, I put lines through my z's because my 2's can sometimes look like z's. So it said step 1, we have to do that distributive property first. And in this case, our distributive property is a 2, and it's positive. 2 times 3z is 6z. 2 times negative 4 is negative 8. This side just drops down right next to the equal sign. Everything stays lined up perfectly. Now this problem looks just like the previous problem. You've got variables on both sides. You have numbers on both sides. And like I said, there's no wrong or right here. If you wanted to take that 5z and subtract it over here, go ahead and try it. See what you end up with. But I am going to subtract 6z, and I'm going to continue to put my variables over on the left side of the equation, just to try to stay consistent. 5z minus 6z is negative 1z. And those of you that already know this, you don't have to put that 1 there. We're used to seeing it in the book as just negative z. Minus 2 is still there. Equals, and don't lose track of your negative over here, it's a negative 8 that we're left with. Since we decided to put our z's over there on the left, we then are going to have to put our numbers over here on the right. Since it's a subtract 2 or a negative 2, we're going to add 2 and add 2. I'm going to write it the way mathematically looks a little bit more proper than instead of a 1. Negative z equals negative 6. You could say negative z equals negative 6, or you could say the opposite of z is negative 6. Well, if the opposite of z is negative 6, then z itself must be positive 6. Anytime you have a negative variable, you can just switch the signs. If you don't like that and you want to show your last step, show divide by negative 1, divide by negative 1, a negative divided by a negative is a positive. Z equals 6. So there's one of each kind of problem. This one did not have the distributive property. This one did have the distributive property. I'm going to have you try each one on your own and see how you do. Go ahead, and I asked you this before, please pause it, try it by yourself, and if you get stuck, then come back and look at the tape, at the video. I don't want you to just like watch me and just follow along because that doesn't really teach you very well. I want to see if you can get through it on your own. So go ahead and pause it and come on back. Okay, go ahead, check it out, see if you did it correctly. Again, your x could have ended up on the other side. You would have had 21 equals negative 3x. But you still should have a final result of x equals negative 7. Last one. With a fraction in it. Last one on this page. With a fraction in it. I told you before that you could multiply by the reciprocal. Take this, multiply by the reciprocal, and just completely get rid of the fraction. You could do that, except for that there's not an answer over here. You might end up causing more fractions. So let's stick to distributive property. When we did it the other day in a different lesson, we only had a single number over here. This time we have 2 different terms, variables over there, variables over here. So let's just stick to the plan. We have 9x minus 5. 1/4 gets distributed. 1/4 times 16 is 4x. 1/4 times 60 is 15. I'm going to subtract 4x from both sides. Minus 4x over here by the 9x. And you get 5x minus 5 equals 15. That's a lot of 5's in there. Two-step solving, always do the addition and subtraction first. Whatever you do to one side, you do to the other. 5x equals 20. And final step is always division, unless it's multiplication. Divide by 5, x equals 4. If you want to plug it back in and check your answers, you can. Okay, last one. I'm not going to do that longer one. Go ahead and try this one by yourself. Distribute that 2/3. Use your calculator. You don't have to know what 2/3 times 6 is. You're supposed to know how to do that, how to multiply fractions and whole numbers, but I'm not here to teach you that in algebra class. You were supposed to have learned that in 5th grade and practiced it in 6th, 7th, and 8th grade. So use your calculator. 2 fraction 3 times 6, 2 fraction 3 times 15. Let's see how it goes. Come back to me when you're done. And we're back. Y equals 4. After distributing, subtracting, adding, and dividing. All right, good luck with your assignment. Do me a favor. Slow down. Do me a favor. Slow down. Show your work step by step. Yes, they're going to take up a lot of room as you do the problems because there's going to be 3 steps, 4 steps, sometimes even 5 steps. But the more room you take up and the more you show your work, the less mistakes you'll make along the way, and it'll actually get done faster instead of taking longer to do because you won't have a mistake up in the middle of your problem. So there won't be as many problems to do as if it was a 1-step or 2-step solving equations because they take longer. So the amount of time on your assignment should be about the same. It's just that each problem takes a little bit longer to do. So be careful. Check your answers. Probably now it's faster to check the odds in the back of the book than it is to plug them back in with a calculator. But it's good to know how to do it on your calculator for quiz reasons. Go ahead and get started on your assignment. Section 2.5, Day 1. Good luck.